All right, so I think I'm recording. Let's take a look at these absolute value inequalities. Um, our first step is to get the absolute value by itself. So in problem number 9, I'm going to multiply both sides by 9. So I have um, x over 2 is greater than, um, well, 13 times 9. If I look at 126, I think that that's 14 times 9. Yeah. And so this fraction reduces. All right, so the absolute value is pointing away from, the arrow is pointing away from the absolute value. So that means that my tails in my solution set are what's going to be shaded, not the center of the graph. So I will have that x over 2 is less than, I change the direction of the arrow, and I change the sign of the number, or I'm going to have this x over 2 being greater than 13 over 14. So if I multiply both sides by 2, I have x is less than negative 13 over 7. And over here, x is greater than positive 13 over 7. And if we sketch that on a number line, we know this is just short of negative 2 because negative 14 divided by 7 would have been negative 2. We needed to determine whether we want to include these critical points, these endpoints in our solution set or not. And we're not going to, because if we look at the original inequality, it did not say greater than or equal to. It was not underlined. So I'm going to leave these as hollow dots. And x less than negative 13 over 7, I shade to the left. And for x greater than 13 over 7, I shade to the right. So here's a graph of my solution set written in interval notation. We have negative infinity, excuse me, negative infinity, comma, negative 13 over 7, or 13 over 7 out to positive infinity. So here's our solution set for problem number 11, written in interval notation. So let's take a look at the next one. The absolute value is not by itself. Let's multiply by each sides by the reciprocal of 5 over 8. So I'm going to multiply each side by 8 over 5. So on the left-hand side, I'm just going to have 31x over 8. Absolute value of that. That's being less than or equal to, I have this 31 over 32, but I'm multiplying it by the reciprocal, which 8 over 5. And this 8 over 32 reduces because 8 goes into 32 4 times. So I have the absolute value of 31x over 8 less than or equal to 31 over 4 times 5, 20. All right, so this time, excuse me, the arrow is pointing towards the absolute value, so I know that the center portion of the number line is going to be shaded in my final answer, not the tails like it was in number 11. So this time I write my compound inequality as negative 31 over 20 is less than or equal to 31x divided by 8, which is less than or equal to positive 31 over 20. I notice that I can divide everybody by 31, and then I just get negative 1 over 20 less than or equal to x over 8 less than or equal to 1 over 20. And now, to get the x by itself, let's multiply all parts of this by positive 8. So when I multiply this negative 1/20th times a positive 8, they're both divisible by 4, so they share a common factor of 4, and this becomes negative 2/5. And this becomes x, and this becomes positive 2/5. So on a number line, we're including our endpoints, these critical points, because of the arrow is underlined. It contains equality. It's in each case, and we shade the middle portion. So in interval notation, we use brackets to include the endpoints. So we have bracket negative 2/5 and bracket positive 2/5. All right, so I hope that helps, and I will talk to you later. Bye.